Good afternoon, everyone, and welcome to our webinar today, Conquering Corrosion for Good, Line Technologies to Transform Sanitary Sewer Systems. My name is Mark Turina. I'm the Marketing Manager here at Geneva Pipe and Precast and ParkUSA. In today's session, we'll be taking a closer look at microbiologically influenced corrosion, a silent but serious threat in sanitary sewer environments. And we'll also be exploring innovative ways to permanently protect concrete wastewater assets. Our presenter today is not only our in-house expert on the topic, but a leading voice in the field. She understands the real-world challenges that engineers, contractors, and agencies are facing, and she's passionate about helping them find the right solutions to safeguard wastewater infrastructure for the long term. So please join me in welcoming Elena Mikhailova. Elena?
Hey, good afternoon, everybody. It's afternoon in Central Time, and somewhere else on the West Coast is probably still morning. So I'm happy you guys join us today for educational webinar. My name is Elena Mikhailova, and I'm a line precast product manager with Geneva Pipe and Precast, and I've been with the company for 4 years so far. Today I wanted to introduce one of the newest technologies you may haven't heard before, but you probably want to know and need to know because maybe you have the needs, or maybe working on the project that you may want to apply this product to. So just to introduce our company, Geneva Pipe and Precast is a Northwest pipe company that was acquired in 2019, 2020. Our footprint is in Utah. You can see the light blue dots in Utah. We also have sister company in Texas, which is ParkUSA, and now we are ready to bring the products by Geneva Pipe and Precast to Texas through ParkUSA facilities. You can see other dots which are dark blue. They represent our facilities of Northwest Pipe for water transmission lines. So for today's agenda, we're going to be introducing line concrete products for sanitary sewer application, and also some products for permanent rehabilitation of sanitary sewer structures. And we're going to go over a couple of case studies that we have done with rehabilitation products. And at the end, we're going to have questions and discussions. And as Mark noted, you should be able to post any questions that you have in a Q&A section. And at the end of the presentation, we will be going over your questions. And in any case, if we're not getting to your question, we will reach out to you by email responding to your question. So feel free, if you have any question throughout the presentation, just drop a question in the Q&A section. So why do we need corrosion-resistant structures in our sanitary sewers? Because the leading cause for deterioration of concrete sewers is microbial-induced corrosion. We all know that over the years, concrete has been used for storm sewers, for sanitary sewers, and with time, we understood that concrete does not last as long under sanitary sewer conditions and crumbles and deteriorates much faster than storm sewer structures. And that's a natural result of a chemical reaction. And very often it goes undetected because a lot of agencies sometimes don't have the asset management programs. They don't survey the structures on a regular basis, and they only find out about the problem once they have an emergency, let's say a collapse in a pipe or a manhole. So why does a MIC or microbial-induced corrosion happens? So when the sewage goes through the pipe or through the manhole, there are organic matters that break down and create H2S gases, and H2S gases, they rise to the top, and that's where you typically will see deterioration of the wall in concrete, and it reacts with cement and creates gypsum. And under the humid conditions, basically gypsum starts expanding and spalling off, and that's a typical mechanism for microbial-induced corrosion. So you're going to have a loss of the wall and eventually potentially corrosion of your reinforcement, which is a structural component of your structure. And in some parts of US, specifically where you have high heat and humidity, the microbial-induced corrosion typically accelerated. You will also see accelerated deterioration where you have high turbulence or high corrosive environments, more corrosive, like elevated temperature of the effluents also can significantly increase the rate of corrosion in your concrete structure. And of course, transit times. So here you see the photos of microbially induced corrosion damage in concrete pipe. So on the left-hand side, this was a photo from Agency of Reinforced Concrete Pipe. You can see some parts of the pipe completely gone. Luckily, this pipe did not collapse, but it's definitely would not be a subject for rehabilitation. It's probably a full replacement of the line. And on the right-hand side, a photo of a structure that has been previously rehabilitated with spray-on liners. As you see, even underneath the liner, the corrosion continued and the liner starts peeling off. And this is a photo of wastewater treatment plant was taken in one of the Utah treatment plants. One of our former coworkers, he used to work for the city, and he knew that they had a lot of concrete manholes installed, and he was asking if they've seen any corrosion in the manholes, and they said no. They were asked to pop the lids and to take a look. So once they popped the lid, they saw this, and there's obvious signs of microbial-induced corrosion in the manhole. You can see some peeling, some gray matter, some odor. Those are significant signs of the microbial-induced corrosion. So how do you identify the corrosion? So if you see the black or white discoloration, the white typically indicates the formation of gypsum, and black indicates the sulfide presence. And then the smell of rotten egg, it's flaking, it's pebbly. One of the signs also, sometimes you will not see the flaking, but you will see pebbly texture on the walls. That also indication that your concrete is gradually deteriorating. Here's another photo, completely different as compared to the previous photo. So here's your ashy type of deterioration of the manhole. And I'm gonna play you a small video. So this was from the rehabilitation of one of the manholes. So before cleaning the manhole, the technician, he kind of like touched the wall just to show like how the wall deteriorating and loses the thickness. So what are the costs? Microbial-induced corrosion can create significant costs for the agencies, for the cities. It's operation and maintenance. You continually have to go back to the manhole and probably spray it to protect, to slow down the corrosion. Then you have to rehabilitate or even sometimes replace. And it significantly reduces the service life of the structure. And you have a risk of collapse especially for the structures like pipes. So what are the corrosion-resistant options that we know of? So one of them is chemical additives. Then very common one, field-applied coatings. Then alternative materials and inserts, integral line structures, and structural rehabilitation. And we're going to be talking about all of them in this presentation. So what are the chemical additives? So what you do, you can add chemical admixtures to concrete and make concrete more corrosion resistant. It creates anti-corrosion properties of concrete. However, these solutions are not permanent. They consider to be short-term, and with time, the effect of the admixture kind of gradually goes away. But it's very versatile. You can add directly to the concrete mix structure, and without any additional manipulation, you can achieve some levels of corrosion resistance. The next one is field applied coating. Field applied coating is one of the widely known method for agencies and municipalities to protect manholes. There's a wide variety of available coatings like epoxy, geopolymers, and typically it's very difficult to determine which one is going to be effective depending on what you have in your systems, how well it's applied, how well your surface prepared. And so a lot of municipalities just deciding by trial and error what's going to work for them. And for these to work, they definitely work. They create a barrier, protective barrier between corrosive environment and concrete wall. But with time, they can physically degrade, can chip and crack, and you may still have corrosion behind the liner. In fact, one of the main failure modes is the pressure that you get behind the epoxy liner. If you have iodine filtration behind the wall, so it will get in between the epoxy liner and the wall, concrete wall, and it starts cracking under the pressure and start chipping away gradually. And so once you have a crack, then you're gonna have continuous corrosion of your structure. So this is an example of the failing field applied coating. Here's another photo of the failure. You can see, and it's also takes quite a bit of time to achieve necessary thickness. You've got to clean it, etch it, dry it, apply it, wait for the layer to dry, come back to apply. So it may take a few days to achieve the necessary thickness of the wall. Of course, with time, newer spray and liners are becoming more advanced, and you can spray much faster to achieve the thickness. They dry much faster in between the layers. So maximum life of coatings can be anywhere between 2 years from what I've heard from the feedback from agencies, all the way to 15 or 10 years. But on average, the failure that we're hearing happens in the applied coatings is about 5 to 7 years where you have to go back and reapply. So another example of failure of coating, it delaminates from the wall. So next one is cured in place manholes, or this is another method for rehabilitating manholes or pipes. This type of rehabilitation gives you some structural rehabilitation. It can last 50 years or more based on the manufacturer information. It gives good alternative for potentially costly disruptive replacement of your existing manhole. Those cured in place installation can have environmental impacts, including water and air contamination, which can be mitigated with proper engineering and construction practices. And also, if it's not installed properly, it can delaminate from the wall, from the host manhole, similar to how the epoxy spray delaminates. So preparation of the surface is also vital for this type of rehabilitation method. So now I'm gonna jump over what does Geneva Pipe and Precast and ParkUSA offers for rehabilitation and as far as corrosion-resistant structures for your sewers. So this is the first product. This is for new construction. It's called Perfect Line System, or you may have heard HDPE line pipe or HDPE line manhole. It's a fully lined system. And one of the biggest differences, it does not require field welding. It's a welded solution that you can install in the field fast. So one of the components of this system is Perfect Pipe. So you can see the illustration on this on the slide. So Perfect Pipe, we offer it in the size of 24 to 48. We do manufacture it in Utah, so this is something to be cognizant about. So if you have a project somewhere, let's say in Texas, and you need high strength, it's a deep burial, maybe high loading capacity is needed, like aircraft or high construction load. This pipe will provide you that strength. We can adjust the reinforcements in the concrete mix to make the pipe stronger. Then one of the system is fully lined, perfect line manhole. It's fully customizable. The available sizes between 48 to 96 inches. And that's where you don't need to have the welding in the joints. But if you need larger sizes, they are available. But the only difference would be you have to weld the joints in the field. So this is a photo of Perfect Pipe. So Perfect Pipe features a coupler. So the black coupler on the left-hand side that is attached into the bell. It's a factory installed. So all that contractor has to do is to home the pipes together in the field, lubricate the joints, and push it in. No welding necessary. So this coupler creates a watertight joint in the pipe. So these liners have anchors, and they integrally cast into the pipe, so they will never peel off. Similar to if you had a spray-on liner, it's not the same. It's an integral cast, so it holds up really well. And so you may have heard previously, PVC liners were very popular. They started off in 80s. It was a T-lock. It had some design flaws, and the water will build up behind it and pull off some of the anchors. The advantage of the yellow HDPE liner has independent anchors. So in case one anchor pulls out, then you have redundancy of the other anchors holding the liner together. So, and HDPE liners are generally thicker, and so they have higher back pressure resistance in case you need it. So let's say if you have deep burial and high water table, you can specify thicker liner for avoiding bubbling like this. So Perfect Line manholes. So now we offer Perfect Line manholes in Texas. We do ship them throughout the country. So it's a fully lined manhole, fully customizable. It can accept any pipe, not just our Perfect Pipe. We can cast in any connector that you need, whether it's RCP, PVC, ductile iron, and other pipes. So one of the features is the gasketed connection, which eliminates the need for welding in the field, and also a turnback. So on this slide, you see there is a turnback in between the liner and the wall, so that creates a 90-degree angle. And on top of that, you have a gasket that overlaps this turnback and completely seals the the gap in between the joints and prevents any gases going into concrete. So these gaskets, it's SDV seal gaskets. It's on top of this, it sits on top of the spigots, and it's self-lubricating, so the contractor does not need to lubricate the gasket from the outside. It's sand-filled on top, so when you place this section on top of the lower section, the sand helps to uniformly distribute the load and create a watertight seal. Our manholes also come with the line cones or lids. They can be either FRP or GTPE lines. So one thing to point out, both FRP, it's a fiberglass reinforced plastic, and HDPE high density polyethylene, they're both corrosion and abrasion resistant and possess similar properties as far as corrosion resistance. I just wanted to show you the slides. This was one of the studies done on fiberglass resin. This was a manhole that was installed in one of the Canadian sewer systems in British Columbia. The manhole was in service for over 20 years, and they dug it up and cut the course, and they measured the thickness of the FRP liner to see if any one of it has been deteriorated or not. And they also looked at the structure of the concrete, and there's technically no damage to the liner or all the concrete. So that just proved that this liner works. It's very abrasion resistant, very corrosion resistant. It can last. So one of the, we can confidently provide 50-year warranty with our manholes. So you can have tall section, you can have short sections. Let's say if you have a project in the with a shallow burials instead of the cone, we can specify the lids. It's also going to be lines, and you're going to get fully lined system. This manhole can accept any type of pipe, as I mentioned previously. All the joints are watertight, and all the pipe connectors are also watertight. As far as the connections to pipes, I know in lots of parts of the US, we're used to having the boots, and for some agencies, the boots kind of like brought in some headache. So let's say and they would require the annular space in between the pipe and the boot to be grouted for the reasons when you have the outlet, so the flow goes in and there's a lot of debris accumulating inside the boot. So, and that's one of the reasons why some municipalities want this to be grouted. So it becomes a maintenance item, right? So the concrete will deteriorate over time and crumble over time. Then you have to go back and redo it again. In some parts of the US, they like having the boot for like seismic zones. So if there is any movement in the pipe, so you have this flexibility of the boot. So I understand both sides, and for your project, you will have to decide which one you prefer. Because we have another option for perfect line manholes is semi-rigid connectors, bell connectors that we built into our manholes. So smaller sizes up to 12 inches, they're made out of polypropylene. So you can see the grooves in here, the several steps. It's for seating the gasket, and also the pipe is going to be sitting a little bit on the upper side, and it will it's going to be a very smooth transition between the pipe and the trough of the manhole. Again, just to remind, if you have any questions, just drop your question in a Q&A, and we'll get to them closer to the end. And so, yeah, so this is a perfect line manhole. So this is a gasket up close. Top consists of it's sand filled for even distribution, and this part slides down. It has self-lubricated on the inside. So yeah, if you're thinking about the total cost, yes, perfect line manholes might be more expensive than sprayed on counterparts. But when you spray your manhole with a coating, you have to go back to it occasional on the regular basis every 7 to, let's say, 15 years. And if you think about the lifetime of the structure, after 50 years, it's going to get so much more expensive, thinking about how much money you spend on, bypassing, spraying, cleaning, versus if you invest a little bit more upfront, then you don't have to worry about maintenance, except for, of course, if it's clogged. So, and HDP liner and FRP liner, they're both very smooth, so there's little things stick to it. And as you know, you can even use a glue to stick to it, right? It has to be like special glue. So it should be very easy on maintenance too. So I'm going to move on to structural rehabilitation options. I think this is one of the hot topics throughout the US, with AAC releasing the infrastructure condition cards. We know the infrastructure in the US is crumbling, and a lot of owners scrambling to what to do. Do we replace? Do we rehab? So we have some options for rehabilitation. One of them is a hybrid PVC manhole. You can see the image of it and the idea how the rehabilitation is done on the right-hand side. So one of the pros, it does not necessarily require the bypass. So if you have a predictable flow, and if you don't have a very high turbulent flow, you can do it in off hours, let's say between 8 and 12 when everybody's at work. You only will need maybe like 20 to 50 minutes to plug the holes and install the base liner, and that's all the time you need. So if you have a small flow or low flow, you can do it without the need bypass. That can save a lot of money, because we all know the bypass can cost thousands of dollars per day. It's very simple, I would say relatively simple installation. It can be done in-house. We have some owners that have done that in-house. Is the instruction on installation is very straightforward. So we would technically provide the guide for installation. We do have some videos as well on installation, and it's very difficult to install it incorrectly. You can also see one of the benefits is minimal number of joints in the system. You only have a joint basically at the bottom where it connects to the base liner, and also at the top where it connects to the lined lids. So that minimizes number of potential leaks, right? Which also is a huge plus. And you don't have to stack them and use the mastic in between where it introduces potential leaks. You only have 2 joints. And this manhole provides not just the lining of the manhole, but also provides structural rehabilitation. So if you have a manhole that's you're thinking potentially you want to replace, maybe think twice, and maybe you can use the system and rehabilitate it structurally. We do provide 50-year warranty against corrosion. In this manhole will serve you 100 years. All the materials are corrosion resistant, and they encased in a grout and existing manholes as well. So initially it might be, again, it might be more expensive than a spray-on option. However, again, you don't have to ever to go back to this manhole to do to it anything again. So it's a very low maintenance from going forward, and you don't need to necessarily to bypass. One of the consideration, so this option only available for manholes between 48 through 72. So if you have 48 or 70 through 72-inch manhole, those would be the candidates for rehabilitation with this method. There is a possibility of larger sizes. However, they will not be the same. They will not be structural as far as like load carrying capacity. It will be basically the liner that you will line the manhole with. Another consideration is reduction in diameter of the existing manhole. So if you have 48-inch manhole, so it's going to reduce down to 42, and this is only because the sizes of available risers are only standard sizes, right? Nobody's going to produce a little bit larger size. So we used what is available on the market. And most of the times, the reduction in size is not a huge deal, because as long as you have enough space, enough room to allow a person there to do the maintenance on the line, that's all that matters. So these are the maintenance holes. So it's a fast, permanent rehabilitation system. So it consists of the base liner. I'm looking at the left-hand side of the slide. So it has a base liner. So that is first lowered into the manhole. So this is a liner being lowered, then followed by lowering of the riser, and then the lids. That's it. Basic explanation. But we're going to go over existing the project that we've done last year for Surprise, Arizona. That was a city. So they reached out to us, and they've done previous rehabilitation of these manholes. It was right next to the roadway. So those are the emergency manhole rehabilitation that were right downstream from the lift station. They did not want to bypass and stop the flow, and they wanted to have permanent solution. Because these manholes have been rehabilitated previously, and the liner kept failing. They did have constrained worksite area because it was right next to the roadway. They did not want to stop a lift station. They wanted to keep going. And they wanted to save money by not bypassing the flow. So what you do first, if you have the manhole that you want to consider rehabilitating, you first have to provide us with a digital model of your manhole. There are quite a few companies these days exist that do scanning of the manhole, and they put it in a digital format, and we will take this format and create a model, our own model, and use a robot to create a custom made mold that will fit the base precisely. Okay. So once we create the negative mold, we spray it with fiberglass and chopped fiberglass in resin. Then once we achieve a necessary thickness, we attach it's called bonding bridges on the right-hand side. So those are the bridges that are going to be embedded into a grout. So that will not allow for the base to move. So this was a liner that we manufactured for those manholes. So this liner is pretty light, corrosion resistant, and also your lid becomes lined as well. So these are the components arrived to the job site. As you can see, you're going to need some sort of a crane, depending how deep the manhole is. If it's very shallow, you may even be able to lower it with a little backhoe. So this pipe is a C900 DR51 pipe, so it's pretty thick walls. Again, it has been tested to support H20 loads. So what you do with the manhole in preparation, first you do surface preparation. So this person is doing it on the live manhole. So he's standing on the pallets, and there is a plastic bag sitting on the pallets, and surface preparation, either just brushing the surface. You don't really need a thorough preparation because it's not chemical-based bonding. It's everything is mechanical. So you prepare the surface, pressure washing or brushing the debris off. Then lower the liner and remember that flow is still going. So now you lower the liner. It sits inside the existing trough. The flow is going. The next step would be to plug the inlet and outlet. You first plug the inlet, let the water from the channel go away, then plug the outlet. So this is a type of connectors we use. So they impregnate it with some resin. And once you install them, they react with water and starts hardening. So they're sitting on the pig inflatable plug. So once they inserted, the plug is inflated and that expands the connector, and it adheres to existing wall of the base liner and existing pipe. So that's how you bridge the base liner with the existing pipe. So you plug both, and from this point on, you let it cure. It cures in about 20-30 minutes. Meanwhile, you wanna grout around the base liner, and once you grout, the grout sets in 20-30 minutes as well, and you can remove the plugs, and from that point on, again, you have the flow going. So again, you only need to plug your flow for about 30 minutes, depending how fast the worker is working as well, right? So if you can afford to plug the manhole, the flow can back up for that long, that would be a good candidate for no bypass option. So then you place the mastic. Once you place the mastic, so the worker is out of the hole and everything else is done from above the ground. So minimal time inside is spent with this method as well, which makes the process safer. Then you lower the riser. So if you remember, the riser is going to be a little bit smaller than your existing diameter. So you're going to have that annular space. So you've got to grout that space. And once you grout it, so the riser is setting tight, and then you place the lid on top. Once you place the lid, so you backfill, compact, do final inspection. So this is just a close-up photo of how the workers have done installing the base liner. So that's a plug on the left-hand side, and grouting the base liner in place by hand. So this is lowering and plugging again. And this is how the connector between the liner and the existing pipe looks like. So it's a sleeve type of connection. So you're going to have a little bit of a lip, but it's very insignificant. It's probably like 1/8 or 1/16 lip, which is very insignificant. It's very smooth too. So this is before. These were the manholes from that project, and this is after. So 2 manholes for that project were rehabilitated in 2.5 days. That including excavation of the cone. I don't know if you noticed, but you do have to remove the cone. So that project took 2.5 days to replace 2 manholes. So this is before and this is after. So you get a brand new manhole that will serve you another 100 years. And if you need steps or stairs, so we can install the polypropylene ladder. We do recommend this type of ladder because it has a minimal number of penetrations, because you don't want to introduce additional penetrations, right? Which can be a potential leaks and pathways for the gases to get into concrete. And these days, everybody's going away from the steps and ladders, and they just use a tripod to lower the person into the manhole. Again, we offer a 50-year warranty on this product. Then you install the grade rings. If you want the grade rings protected, there is a chimney, corrosion-resistant chimney that exists. Then you put the frame and cover on top with the mastic. So on the left-hand side, there's a corrosion-resistant grade rings. There are several available. There's one from Cretex, or some they are Pro rings, and HDPE grade rings also exist. So whatever your preference and whatever you allow on the project can be used. There's also an option of not rehabilitating the bench area. So what you do, just I guess fix the benching area, troughing. If you have the flow going, you can't really do that. You can only rehabilitate the benching area, and you would decide like whether you want to fix the benching based on like, do you have a lot of corrosion in it? Do you have a lot of loss of concrete? And if you don't, you just might want to just epoxy it and just rehabilitate the riser and the lid. And if you have a drop manhole, so hybrid PVC manhole can accept drop pipes. We do have this drop bowl. It has a little lid on the side that you can remove and maintain the pipes. All right, so I'm done with hybrid PVC manholes, and I'm going to move on to the next product that we offer in next, last but not least. It's a composite FRP rehabilitation panels. So these panels, they are suitable for square structures. Right now, we do not have an option for round structure. However, for wet wells, if you have square lift stations, these would be the perfect candidate for rehabilitation. So these provide permanent rehabilitation solution. Again, it's not a spray and liner. They mechanically attach to the wall, and they will never come off or peel off. It's a fast and simple installation. We have training options available for the contractors who want to install these. These are easily customizable, so you can work with this product kind of like a drywall. You can cut it to the shapes, to the size that you need right in the field. They're lightweight, so they don't require many people to work on these. The person can lower these panels inside the hole by himself. And we offer 25-year warranty on these panels, and it has a 100-year lifespan. So this is the composition of the FRP panel. So inside is a polypropylene honeycomb structure that gives the rigidity to the panel. And one of the advantages of having a rigidity, you can use these panels as the formwork. Let's say if you want to restore the thickness of the wall that was lost due to microbial-induced corrosion, you can use this as a formwork, and you're going to be killing 2 ducks in one shot, restoring the thickness and lining the structure. So the outside is FRP. So this is the same resin that we use for our perfect line manholes. It's a corrosion resistant. So what you do, you first install the panels on the floor. If you want to rehabilitate the floors, you don't have to rehabilitate the floor. So if you have constant water sitting on the bottom, you may not want to do anything to it. But if you do, that's an option. So the panels will directly go onto the floor. You can either use self-leveling concrete to level up the floor so the panels sit flush. You will not use grout at the bottom, so you will mechanically attach them with concrete anchors. And once you install them, then you seal the seams and so on. So let's look at the case study that we did for Bullhead City in Arizona. So this was a wet well rehabilitation. They totally had 4 wet wells that they wanted to rehabilitate. Previous rehabilitation methods have failed, and as you know, spray-on liners, they will require some bypassing and drying of the wet well applying, and that can get very expensive if you're doing several times. So this wet well was 2,700 cubic feet, 0.6 to 0.7 mgd flow rate, and they were looking for permanent solution. And they were pretty large structures, so it would have been very expensive to excavate and replace. They also had some constraints on the job site. It wasn't in a residential area surrounded by residential houses. The work area was pretty tight, so they did not want to do any disruption for inconvenience of neighborhood. And again, they wanted to do the minimal bypassing of the pumping to save on cost. So the panels themselves, they about 30 inches by 60 inches, and that size was specifically designed so you don't have to remove the lid of your wet well, so you can directly feed it through the hatch without the need of removal. So you don't have to excavate anything, and you can feed the panels directly into the wet well. It has anti-corrosion properties as well, just like our perfect line manholes. So this is one of the submittals for our panels. It describes the honeycomb structure, the size, the thickness, the compressive strength of it, in composition of the panels. And this would be a submittal drawing to the engineering or to the owner. If your wet well is too complicated, we probably will have to scan it to determine the size. If you don't have as-built dimensions, if you have any penetrations, exact location, and we would count based on that. We will count how many panels you're going to need and what type of panels you're going to need. So surface preparation, again, is not super extensive because it's not a chemical, they're not attached by chemical adhesion. It's a mechanical attachment. So pressure washing will work. Again, you may, if you do lining of the floors, you want to do leveling of the floors, then panels installed across the floor, and then bolted to the floor, and then you seal the seams. Then you move on to the walls. Once you have the floors, you install panels row by row. So you repeat this process. You install it on the wall, one row, seal the seams, and grout behind. So again, you can cut it right in the field. It's very easy to cut just with a circular saw or jigsaw. And you're going to have a fully lined structure at the end. So this is a process of installation. You have some, once you transition from the floor to the wall, you have ledgers installed. So you can see over here bolts. They will be sealed with epoxy at the end. Some more pictures. This is a lining around the openings. And this was one of the lift stations that we did for the Bullhead City. I think this is an amazing application of FRP panels and where it can be super useful. There's a lot of wall thickness was gone in this lift station. Also, some damage to reinforcement. So they use these panels to restore the wall thickness. They placed a new reinforcement in the places where it was gone and where the wall was deteriorated. Typically, we only have like one thickness of the panel in between the wall and the panel, but in this case, it was 3 thicknesses. So it's about 2 inches worth of the wall was gone, but they were still able to rehabilitate and restore this wet well because they use this system. With that, I would like to wrap up my presentation. We have about 10 minutes before the end of the time for this presentation. So let's look at some Q&A section.
Awesome.
The first question was, what is the load rating for hybrid PVC manholes? Yes, it is rated for highway load. It's a H20 load rated. The next question, is there give and take in the line sewer manhole if a pipe connection to manhole needs to be raised or lowered in the field? So again, the openings are made for specific location, right? So we make the liner, we cast it into the manhole. So the only way you can have a little bit of give if you need to raise it, I don't know how much you need to raise, but if it's just a few decimals of inches, then you can probably use a boot in order to adjust it. But otherwise, no, you'll have to, if it's few inches, you probably have to drill a new hole or make even new base for it. But if you have a specific case that you were thinking, yeah, feel free to shoot an email to me, and I will look at it and will advise. What hydrostatic pressure can the manhole accommodate? So the manhole up to 30 psi, that's what our joints were tested for. But again, we do recommend it. It's a gravity manhole, so standard we guarantee 13 psi. Then question, how does one add an additional sewer laterals into the perfect pipe or line manhole? So if you wanted both of them, you can add additional lines. We had that done on the manholes in some pipes. So what you do for the pipe, you will core the opening in the field, and there is a special connector made by a fabricant that will just kind of like a screw in cans on one and the other side. I don't have a picture of it. I did have on the slide, but I removed it because I was not expecting this question. But yeah, it's possible to add lateral in the field. And for the manhole, would you have a procedure how you would add a lateral to in the field? You just core through it and make a new corrosion-resistant channel through the bench, either by using PVC pipe, like half of PVC pipe, or fiberglass mats impregnated with resin. Do the inlet pipes also use a similar gasket connection as the joints? I'm not sure which joint is referred here, but both inlet and outlet pipes use similar gasket connections. But the joint between the sections is different, the different gaskets. What is the life cycle of the line manhole as compared to online? So online, it depends where it is, right? So we guarantee our line manhole life cycle for, it's a 50-year warranty against corrosion, and it's designed for 100-year design life. If you have online manhole, it depends where you're at, really. We heard some manholes can corrode in 5-6 years if they're in a very aggressive environment. Typically, it's like in a dairy farms or some where you have an elevated effluent, they can corrode away pretty fast. But some manholes, online manholes, can last 50 years if it's not a super aggressive environment. 2 more questions. How much preparation is required? I'm assuming the preparation for rehabilitation. So the preparation for rehabilitation is you only need pressure washing for the most part for both PVC manholes and FRP panels. Yes, are you getting the AgriLiner approved already in Texas? I am working on getting the liner approved in Texas because, as you know, like you have to go agency by agency. If you have a specific agency in mind, just let me know. We can accelerate it, but that's the goal for these line products to be approved in Texas. Well, we appreciate you attending the presentation. I hope you guys learned something new and you see how you can apply these products on your projects.
Thank you so much, everyone, for spending this hour with us, and thank you, Elena, for going over this presentation. We really appreciate it.
Yeah, thank you, everybody, and thank you, Mark.
All right. Have a great day, everyone.